Hello. Okay, so this week we're going to start looking at something a little bit different. Up until now, we've been talking about equations. Okay, so we talked about variables. We know the variable is the part of the equation that was unknown. And we figured out that if we want to solve an equation to find the value of that variable, we always want to get all the variables on one side, all the constants on the other, and then find out the value of just one variable. The difference this week is we're going to start talking about inequalities. So inequality means something a little bit different than an equation. Okay, so when we're talking about an equation, we want to find the one answer. The difference with an inequality is that there can be a whole bunch of answers. Okay, but there's some answers that are not right. Some answers don't work, so those wouldn't be answers. Only the ones that do work in the inequality are the right answers. Okay, so we'll see what that means today. If we look at the introductory page here, we look at this parking sign. We see signs like this all the time. It says, okay, yes, you can park, but only for 30 minutes. Okay, so that means if I parked for 10 minutes, that would be okay. If I parked for 15 minutes, no problem. Park for 25 minutes, I'm good. I park for 30 minutes, that's okay. But as soon as I go over 30 minutes, I could get in trouble. I could get a ticket. So 31 minutes is not okay. That's not an answer. That's not an acceptable amount. What if I park for 35 minutes or 40 minutes for an hour? That's too much. So that does not satisfy that rule. Okay. So if we were going to write, look, which of these inequalities describes the time t minutes? So if we're saying, okay, we're going to use a variable because we can have different values for which a car could be legally parked. Well, the first one's saying t is greater than 30. So that means any amount over 30 is good. So we know that's not the right answer. Okay. The second one says t is greater than or equal to 30. So that means 30 minutes is okay, or anything above that. That's not right, so it's not that one. This one says t is less than 30, so that means anything under 30 is okay. Okay, that's closer. The last one says t is less than or equal to 30. So the difference between these two is that the last one includes 30 minutes. So 30 minutes is okay, and so is everything less than 30 minutes. So that last one right there would be our right answer. Let's look at some more examples like that. If we look at this page, look at this. These are all situations that could be represented by an inequality. Okay, so if we look at the speed limit sign, it says the fastest we're allowed to go is 55. This must be American, right? 55. So I can't go anything over that. So that's just like what we had on the last page. That's the maximum. So if that's the maximum, then I would say anything less than or equal to this is okay. So maybe I would say, let s equal my speed. So I'd say s can be less than or equal to 55, okay, because that's the maximum. Look at the next one, height restrictions. This is when you go to get on a roller coaster or something. You must be at least 102 centimeters to go on this ride. Okay, well, that means that's the minimum. I can't be under that amount. I have to be that or over. Okay, so this is a situation where we'd say, okay, so if h equals height, h has to be bigger than or equal to 102. It has to be greater than or equal to 102. So that one's a little bit different. That's different than this, right? This is where this is the maximum, so I have to be under that amount or equal to it. Whereas this one, it's a minimum, so I have to be over it or equal to it. Same with the milk. Look, the milk has to be stored below 4 degrees. Okay, so 4 degrees is too hot, so it has to be less than or equal to 4. I said M for milk. Milk has to be less than or equal to 4. And look at the last one. On a movie, look, 14A. So that means you have to be at least 14 years old in order to watch that movie. So this is a minimum again. So we're going to say that age, we could say A, has to be greater than, bigger than, or equal to 14. Okay, so that's some examples of how that works. Let's see some more inequality statements. one expression is less than another. So we'd say A is less than 3. This is how you would write it. A less than 3. If one expression is greater than another, B is greater than minus 4. B, and it goes this way, greater than minus 4. So B has to be a larger number than minus 4. C is less than or equal to 3/4. That's how we would write that. So see how the symbol has a little line underneath? That means it includes that value. So C has to be 3/4 or less. Okay, those are both acceptable amounts. Or here's another one. D is greater than or equal to minus 5.4. So we have D greater than or equal to. So it has that little line too, minus 5.4. Alrighty, look at this. No, let's not. Okay, so first example, define a variable and write an inequality to describe each situation. Look, contest entrants must be at least 18 years old. So we would say, okay, well, if A is age, we're going to say, okay, you have to be at least 18. So 18 is the minimum. So you could be 18 or over. So A has to be bigger than or equal to 18. Okay, look at the second one. Temperature has been below -5 for the last week. So the temperature has been -5, or it hasn't been -5, it's been below -5. So the temperature is less than -5. So see how there's no equal to here? That's because it didn't say it was -5 or below. It says it was below -5. So it's only values that are less than that are okay. That's a little bit tricky there. Okay, is each number a solution of the inequality B is greater than or equal to -4? Justified. Okay, so let's see how we do that. So we can use a number line. Okay, so what do we do with the number line? Well, we're going to show on the number line, okay, if we know that B has to be bigger than or equal to -4, so we put -4 on there, and then we know that -4 and everything to the right is acceptable, okay? Those are all going to be values that we say are okay. Okay, so anything to the left of -4 is not okay. And see how there's a little circle on -4 and it's colored in? That's important too, and we'll see why in a second. So if we look, oh, there's all these different values, and we say, is that okay? Is that okay? Is that okay? Well, let's look. Okay, so if we said -8, where is it? It's over there. Not okay, right? It has to be here or to the right. -3.5, there it is. That's to the right of -4. That's good. -4, yep, because we said that that was included. That's why it says equal to here. -4.5, nope, that's on the left. And 0, yep, because it's on the right. This solution I find common sense, but okay. So what it's saying is you can take each number that it's asking about and put it in as B, substitute it in, and then see if this is true, right? So if you write B is -8, so we write -8 on this side, keep -4 on that side, you look at that statement. Is -8 greater than or equal to -4? No, so that's not a solution. That's how you would do it that way, substitution. Okay. Let's graph these on a number line. We'll just look at the first two. Okay, t greater than -5. Okay, so I have to start with -5. And I'm saying anything bigger than -5, anything greater than that, okay? Now remember, these are negative numbers, so even though 6 looks bigger than 5, it's not because it's more negative, right? These are getting smaller. So anything greater than -5 means anything to the right of on the number line is good. So see how that's colored in? But on the -5, we have an open circle. That's because it's not, the equal sign isn't here, okay? If it said t is greater than or equal to -5, we'd color in that circle because 5 is included. But when you leave it open like that, it means that 5 is not included. Okay, and then it gives a bunch of solutions. There's anything over here is okay. So you could put any of those things as a solution. Anything that falls on that red line. Look at the second one. -2 greater than or equal to x. Okay, so If -2 is greater than or equal to x, look at it from this side. Read it from the x side. X is less than or equal to -2. Right? X is less than or equal to -2. So we draw a -2. We put a circle and we fill it in because there's the equal sign there. And we're saying it has to be less than that. So anything to the left is okay. So you could pick -3, -4, -4.5, -5.2, whatever you want. Anything to the left is okay. And -2 is okay as well because this one has the circle colored in. Oh, this is just more of the same. I think we're done. So how is the solution of an inequality different from the solution of an equation? With an inequality, you have a whole bunch of solutions that are good. Okay, so you can pick any of them. Any of the ones that fall on that colored red line are possible solutions. With an equation, you only have one possible solution, usually, the ones we've seen. Thanks. Good luck this week. Beautiful weather.